Welcome back guys, and here in this video we'll see that a few more methods of linked list and we'll try to understand, right? So in previous video I told you when you should make a reference of list, an object of linked list, and when basically you should make the reference of linked list and object of linked list, right? So here we will not again repeat the same thing. We'll go to the some other methods which we have. If you look at here I have a linked list which has some data, okay, and I have one more linked list which has some data. By this time we are very good with writing the how we can create the object and how it works. So I have the code which is already typed. So here again I'm not going to make the object of linked list by showing you that's how you can make. Okay, by now you should be comfortable. So you have now two object. So in linked list we have a multiple ways to add the data. This add data, you guys know that, right? This will add the data at the end of linked list always. So when you add the data, the data will be like A, B, C, D. D will come at the end, and then from end C will be the second last, and this is the third last, and this is the first one, A, right? Because it maintains the insertion order. Linked list will maintain the insertion order, right? So add method, you are very familiar. It will add the data, and this also I have shown you through the diagram. When I started the linked list, first I have shown you the internal implementations, right? So by now you should be aware of. Now there is a method called AddAll method. So how this will work? This AddAll method, what it will do, whatever data you have in the linked list, this AddAll method internally it will go and add all the collections of object, at the end of the linked list. At the end of the linked list. See, if you really want to see that how this works is, click on control, click on AddAll. If you go to this method, what this guy will do, it will do AddAll. So again click on control, click on this method. If you go to this AddAll method, this AddAll method, basically what it will do, it will run a loop, okay, and it will run the loop on the existing object, the object on which you are going to add the data. It will move to the pointer till it will get a null, right? Null means your first set of linked list data is over, then at the end it will go and it will add it, right? So that's how the complete AddAll method works. This is your data structure implementations. Anyways, I will cover in the data structure, so here you don't need to bother, and you should not know also here you should just know how AddAll method works in the collections framework, right? Because collections framework has given you the facility, you should know how it works, okay? So AddAll method, when actually go and if you print this, you can see that the all data will get added at the end of the list. See here, you can see that after A, B, C, D, if you look at A, B, B, C, D, so A, B, B, C, D got added after first object, after first collections of object, right? Now in AddAll method, if you go to this reference again, and if you print dot a double d, so look at here how many methods you have. You have a lot of methods. So add first, add last I have already covered, add is already covered. Now we are covering add also, this is covered now. Now here in the AddAll there is another method called one more AddAll. These are all overloaded method, okay? This method basically, this will help you to add based on that index, like from where you want to add, right? So this AddAll method, so if you look at here the second AddAll method, I want to add my second collections of object after index 1, right? After index 1, right? So basically it's from index 1, not after 1, because this is inclusive, so if you look at the output, what will happen on the first index, your second collections of object will start. Look at here, so let me go over it. So if you look at, this is your 0 index, this is your first index, this is your second index. So basically what happens when you show AddAll first index, which means this is inclusive means on first index A will start. So see, you can see that A, B, B, C, D, so this all got inserted, the second collections of object got inserted, and then again B, C, D, A, B, C, D continued, right? Then everything continued. So that's where this AddAll based on index will help you, like it will go and it will insert on the particular index which is 1. This is the one, it will start from here, it will insert all the collections of object from second collections of object, and then again whatever left out in the first object, list of collections of object, it will get inserted after that, right? That's how it works, like in positions. Now in the linked list there is another method where you can add based on the index. So if I want to add here, I on let's say on 7 on let's say on second index I want to add this. Okay, on second index I want to add triple A. So how this will work, how triple A will get added on the second index? You can, this I'm printing it, right? This linked list one I'm printing here. We can see that how this will get added. Okay, so if you look at here, when I'm trying to add, I'm getting that Java index out of bound exceptions. The reason being is in my linked list I have only one data which is nothing but which was added at the 0 index, and then I'm trying to add on the second index. So of course I will get array index out of bound exceptions. I cannot do that. But same thing, once I have two data added here, right? Now this is 0 index, this is 1 index, this is second index. So on CC AA will go, right? So look at here, here you can see that here on CC what happened is all your this linked list you are printing that, right? So let me comment other print. I don't want you to get it confused. Just keep only one print. So look at here, when on why it is getting, oh sorry guys, the problem is I was not printing list 1. I should have printed list 1 here, sorry. Okay, the problem is after adding list 1, after in the list linked list I have added list 1 and then I'm printing here. So I should have done here, just after the additions I should have printed linked list 1 so that there is no data manipulations. You will get only linked list 1 data. Okay, I don't want to add and then print, so you will not be able to see that how it is working. Now you can look at here, now it will be clear for you. It was AA BB and it's supposed to come CC. Ideally it's supposed to come CC, but since on the second index you have added triple A, so triple A came here, then CC went and then DD went, right? This is this what it is. So you did a add all method, okay, and when you did add all method you are printing linked list. Okay, you are printing linked list. So the same data got inserted after first collections of object, right? So hope it is clear, all methods are clear. Here you can also add based on the index, it's up to you. So these are all additions we have seen that. Similarly in the linked list actually we do have removal. Okay, so when I talk about the removal, I'll keep both the example. I'm not going to remove anything. Okay, removal, how it works. So there are multiple ways removal works. One is dot remove. Okay, so if you look at here, remove also you will have multiple methods in the remove. Probably few methods you don't have in the array list. What you don't have the array list is remove first and remove last. So this you don't have in the array list, right? As of now you have seen that add first, add last, get first, get last. This is same thing, remove first and remove last. So when you do remove first, what this guy will do, this guy will remove the first object in the linked list. So to see that how this is getting removed, you can just print the linked list. In output you can see that A will get removed. Okay, if I have to print this, run a Java application, see A will get removed and only BCD will get printed. Similarly after remove first, when you go for remove last, right? So first you have already removed, now you are removing the last. Okay, and again when you go and print the linked list, Now the last will also got removed and your answer will be only B. Yeah, remove last. So actually it was BCD, right? So D also got removed. Now the answer is BC. Okay, answer is BC. So you can see that how remove first and remove last worked. So now in this existing list the D also got removed. So this is the two method which you don't have in the array list, which you have in the linked list. So let's say when you want to use this method, you have to make the reference of linked list and object of linked list. You cannot now make the reference of list interface, because list interface will not have this method remove first and remove last, because this is very specific to this particular linked list class. This is not present in the vector also, this is not present in the array list also, and you know that all three classes implement the same interface. So you cannot keep in the interface, you have to keep in the your child class, because only this class should know what is remove first and remove last. Okay, now similarly there is a method called dot remove. So you have multiple remove method here. We have seen that remove first and remove last. Okay, two method we have seen that. Now there is something called remove. So look at here what this guy will do: retrieve and remove the head of the list. So look at here, this remove, what it will do, it is nothing but like it will remove your head. So now if you go and you just call a remove method, and when you print this list, basically right click, run as Java applications, you can see that now your B also got removed, because you are performing the actions one by one. So from the same list, first you removed first A got removed. Let me also print the actual list so that you can clearly make out the difference, like how this remove method works in the linked list. So first time that this was the original linked list, then you remove first got removed. Here you have remove first method, right? Then you have remove last, your D got removed. After D, this is the output BC. Now you did remove method, remove will remove the head, which is head was B. So now C is left out, right? C is left out. Apart from that, now I will come to this list, I'll perform some actions on this list. Now there is a method called remove based on index and based on the object. So I'll remove second here. Okay, I'll remove the second, this is one, and then also I'll remove based on the object. So the object is, I want to remove A. Okay, two things here. Here also to show you, first I will print the original linked list, and then I'm removing the index second. I'll print this and then I'll print this, right? So how this will work is, first it will print everything, then I'm removing second means this is 0, this is 1, this is 2, but on the same index I have overridden, so basically it will remove this one. This is not 2 anymore, because on the 2 we have overridden this, so this guy become 3. So what it will get removed, this one will get removed. And then when this is already removed, and when you try to remove the same thing, right, so what it should say, no such object found. See, look at here, this is your first. Okay, let me put the demarcations line here. Just be with me, try to remember all the methods. These methods are very important. Look at here, this is your first operations which I performed on the first list, like remove first, remove last, then remove. 3 operations performed, and this was the final output. Now on the second list, if you look at here, I did remove second, so this was my original list. When I did remove of second, this guy got removed. Then again I did remove, so again when I did remove, nothing happened basically, because this was already removed. So if you go to the remove implementations, press Ctrl, click on remove. Look at here, this return type is the boolean. Okay, and this method will not throw. I was thinking it will throw the exceptions, but this method never throws any exceptions. Okay, so either you will get true or you will get false, nothing else. So basically if you have to print that, when you have to print this, you can see that this should give you false, means this fields is not removed. See here you are getting it false. False means this particular field is not removed, it was not present at all. But instead of that, if I do BB, so what will happen now? Yes, it will get removed. Sorry, cancel. Here also do BB. No, don't try 2 times. Just write in the print statement. This is also fine. It will delete, no problem. Okay, you can write in the print statement also, so that your output will get printed. So when you remove now BB, what happens? See, return type is true, means BB got removed, and this is the output. So if you look at AAA was removed by remove of second index, and then I did remove object BB, this way also got removed, right? There is some other method in the remove. There are a lot of methods in the remove. When you do dot remove, so we have covered remove this based on index, based on object. We have covered remove first, remove last, right? And then we have something called remove all. So how this works, remove all, how this will work? So when you do remove all, basically it will remove the entire collections of object, right? So for that, what we have to do, that is we have to create one more list. So let me create one more list called list 3. Okay, and let me add some data in this list just to show you. Okay, I have added DDD quite number of time, and then in this I will store AA and I will store DD, right? And I will do remove of this list 3, and then I will print list 1. We will see that what is the output. Okay, so if you look at here, basically just run that. Okay, run that, everything will be clear. So look at here, this was the result when we printed this list 1, right? Here when this line, the line number 41, after that this was the list. After the all data manipulations, we actually run a lot of methods on this. Then what I did, if you try to understand, we did on the list 1, we performed remove all list 3. Okay, when we did remove all list 3, and so one mistake I did here, you have to do like on this list 3 you have to add that, because I was seeing the difference in the output. Okay, so if you look at my list 3, I have added AA and DD, and then I'm saying that from list 1, which was this, after all data massage, remove all list 3. So when you do remove all list 3, which means it has a data of AA and DD, right? Literally it has AA and DD. So what this will do, it will go and match AA and DD in this list. So whatever AA and DD matches, it will remove everything from the list. So this all 4D will get removed, all A will get removed, only the left out will be what you had. So this was the list. After this all removal, this is the left out. To make you understand in better way, what I can do, select this, do control backslash, it will get commented. Okay, so I'm not performing any other operations. Now for you it will be very easy to understand. Look at here again. First I have to print this list, like what was the original list and what happened after deletions. You can correlate. See, look at here, this was the original list. When you did a remove all linked list 3, your left data is only BB, AAA and CC. The reason is this AA and DD, wherever it will match. So you have A here and you have DD here. Then what is left out? Left out is this, right? So this will get printed. In earlier this was not getting printed because we were also removing bb here and we were also doing remove too. So I've just commented for your understanding. So that's how remove all method will work, right? Now again I will comment this, I will not keep open this. Okay, now I will also comment this, select control backslash. We will call some other method on this guy, on this list object, dot remove first occurrence of, remove first occurrence of. So what does mean by remove first occurrence of? It will remove the first occurrence when the data was started. Let's say you know that list allows you to store duplicate data. You want to store, you want to delete the first occurrence of. Then how do you do that? You have to call remove first occurrence of and then print the list. So you can see that the first occurrence of dd will get removed, right? First occurrence of, and this is return type is the boolean, right? So just to explain you, what I will do is here I will add one c so that you can understand what is the first occurrence, right? If it is in the sequence, you might get confused. Look at here, this was your original list. So the first occurrence of c was here, right? So what I will dd, sorry. So first occurrence of dd was here, and then we had two more occurrence of dd here. So when I called remove first occurrence of dd, see this dd is gone from here, and you have after cc you have triple cc. So this is your removal of first occurrence when it will match first time. Okay, so dd got removed. Now when you do last occurrence of, so to again to show you last occurrence of, same thing, just do dot remove last occurrence of. Okay, so this guy, what it will do, it will remove the last occurrence of the list. Again I will print that so that it will be very clear for you. Right click, run as Java applications. See, look at here, the last occurrence of dd got removed because after removing the first occurrence of dd, there was two dd here, there was two dd here. When I call last occurrence of, this guy also got removed, right? This guy also this guy also got removed. Now you have only one dd, so this will remove the last occurrence of dd, right? So that's how remove works. Anything left out in remove except than the feature which came recently? So we have covered remove based on object, remove based on index, based on object, remove all, yes, remove first occurrence, remove last occurrence. The left out is remove if. So what is this remove if? See, in this remove if you can write a lambda expression. Okay, so this is very simple. What you need to write one expression here is, you can just write let's say, what is the data type, what is the data type you have in the string? It is a list, it is the list type. So what you can write, you can just write n, right? And you can write if n dot contains some conditions, okay, in double quote triple c. Okay, if this contains remove. So this is a lambda expressions, guys. So actually what happens here is, yeah, so how this will work, I just did command shift F. So this line you can take it outside, I will explain you. So how this expression works is, so in this list, okay, I cannot write expressions like this, just to explain you I'm writing like this. So how you can write is, in this list, whatever list you have, this list, okay, run the loop on that. Internally it will run the loop, and you check n dot content. So what is n? So when it will run the loop on this list, right, one by one it will fetch the data from the list. One by one it will take a b c c. So one by one it will take the data. When it will take one by one the data, it will get assigned to this variable, right? It will get assigned to this variable n, and this is the lambda expressions. Like what expressions you want to perform, that you have to write. You have to put one angle bracket and then a space, hyphen and angle bracket, and then you write n dot contents. If this is the expression, then only remove it. I will cover Java 8 separate so that you will understand very well. Here just try to understand this small example. So you can write one conditions here. Same thing I'm doing, that if n, right, this is the arrow mark that contains, right, this, then remove. So what will happen? Your triple C will get removed, and if you try to print, you can see that your triple C got removed from the list. So it is very useful. Lambda expressions are very useful. Your multiple lines of code will be in the single line. See, in general, when you have to remove one data from the array list, you have to write one for loop, iterate over the for loop, put one if condition. If this contains this, then remove, right? Everything you can do in the one line. You can just write n contains this, remove. So you can see that after processing, this was the list. From this list also we removed triple C. Now this is the output. So with this we are done with all remove method of the linked list. Thank you guys. Thank you for watching this.